All right. So, hi everyone. My name is Crystal, and up to very recently, I used to work as a staff developer at Shopify, leading the technical vision of the data visualization system there. It's a library called Polaris Viz that was recently open sourced. And just a quick personal updates. I've actually left Shopify last month to join Human First. It's a company that works with natural language understanding. They have a very powerful platform. But today, I'm going to talk about the last thing that I did at Shopify, which was Polaris Viz, why I created it with the team there, how we did it, and lastly, how we actually managed to share a bunch of code that we originally had built for web with React Native. So I think that to better understand what Polaris Viz is, I think that we can talk a little bit about what data visualization looked like at Shopify before we had our own library. So these two examples here used to live together in the admin platform of Shopify. And as you can see, they are not that consistent. One of them has vertical grid lines, the other one doesn't. They also have different line widths, different dashed line styles. One has squares on the legend, the other one uses lines. One has a visible x-axis, and the other one doesn't. And these inconsistencies were caused because each team at Shopify was responsible for making their own decisions in terms of choosing which library to use or creating something from scratch. These inconsistencies were not only visual, though. Because they use completely different implementations, one had print support, the other one didn't. One had some really basic keyboard navigation, and the other one didn't have any accessibility at all. But I think that my favorite one was this thing. The area label of line chart of sales over time. I'm not sure that if I was using a screen reader, that would actually help me understand how my sales are going. And even when teams started to use the components that we started to build in-house, we still had a bunch of visual inconsistencies because the API of the components looked something like this. You had to pass a bunch of style props over and over and over again. And of course, it was very easy to make mistakes when you had to copy and paste so much. So to solve all of that, we started creating this collection of components that we later released as Polaris Viz, which is basically just this. It's a library of React components built on top of D3. But what was very interesting for us is because we created it from scratch by using D3 as a math utility function and for layout calculations. We also had a lot of freedom to to focus on the things that were very important for us, like accessibility, not only for screen readers, but accessibility in general, and also motion design, because we really believe that motion design does not necessarily have to be only used for delight, but can also be used to actually guide the user's eye and make them better understand what's happening in a data chart. A good example of this is how we actually allow the user to highlight some data series by interacting with different parts of the charts. And that allows you not only to focus on one specific data series, but also helps folks that have color vision deficiencies to understand what data series is connected to what elements on the legend without relying only on color. All of our charts are also use area rows so that a person that is using a screen reader can actually navigate on the line chart that is an SVG under the hood as if it was a regular HTML table. So you can see here that using VoiceOver, I can actually navigate the cells by rows and columns exactly like you would do with an HTML table. And to keep things consistent, we also implemented themes so that other Shopify brands like Shop, Handshake, or Burlo, or maybe your next application, because I mentioned that it's open source now, can actually apply your own visual identity without creating yet another inconsistency in your application because you're using some different colors or different styles. So in 2020, Shopify announced that React Native was the future for the company, and all of the teams have been focusing on writing mobile experiences using React Native since then. For our team, this was a really good opportunity for us to start thinking about how we could use the things that we learned while we were creating data charts for websites in mobile experiences. Okay, but before we actually start talking about, how to reuse things in React Native, let's go briefly, let's have a look very briefly on what exactly did we do to build these charts. So as I mentioned before, the charts are built with SVG and Z3. In case you haven't worked with SVGs for a while, I'll go super fast and do a 2-minute SVG refresher. So SVGs are pretty much like HTML. You create an SVG by declaring an SVG tag with a view box that has 4 numbers. The 2 first numbers are an X and Y coordinates for an origin point. And from there, you have the width and the height of this area. So you can think of a view box kind of like if it was a window to look inside of the SVG world. And inside of that window, you can draw different kinds of shapes, like polygons, for example, where you pass a sequence of X and Y coordinates that are going to define where the vertices of that polygon is. Or a rectangle, which is the same thing again. Most elements in SVG are always going to work like this. X and Y coordinates from top to bottom and from left to right. So an origin point that is defined as X and Y, and from there you have the width and height. Similar to the circle, the only difference here is that the origin point of a circle is going to be in the center, so CX and CY. And then from there, you define how big that circle is by specifying the radius. And lastly, we have paths, which are by far the most powerful way of creating shapes on SVG because you can pretty much draw anything with a path. And paths work like that crazy sequence of numbers and letters over there. You can think of like if you had an imaginary pen, and then you pass commands to this pen. So, move the pen to X and Y, and from there, draw a straight line to X and Y, from there, a curved line to X and Y, so on and so forth. Okay, so I think I kept it under 2 minutes. That's it for SVGs. The other parts that we use to play with SVGs is D3. And D3 is very, very cool. I mean, probably most of you have seen very, very nice examples of the things that we can build with D3. It's a very powerful tool. You can do all sorts of data visualization and animation and everything, really. The problem is with D3, though, is that it can be very hard to know where to start. Like, this is a screenshot of the GitHub docs, the API reference of D3. Look at the size of this thing, So to keep things simple, I think that maybe we can define what we're not going to use from D3 since we are using React. Because as I mentioned, it's a very powerful tool, but it also has a lot of things that we don't necessarily need. And a good example of that is D3 selections. So we are not going to use this module because we don't want D3 to actually keep control of the DOM. We are going to use React for that because that's what it does best. So everything that is related to DOM manipulation is going to be from React. And we are going to use D3 for what it does best, which is going to be doing math calculations for us and layout calculations for us. So a perfect example of the kinds of things that we are going to use from D3 is D3 scales. So scales are functions that map from an input domain to an output range. So to give you a quick example of what exactly that means, suppose that we have a really simple data set, like that inputs array over there, 0 to 150 and 500. And I want to map those numbers, that data source, to some positions on the screen. Like in this case, I'm mapping the data source to the horizontal position from left to the right. The available screen space that I have goes from 0 pixels to 330 pixels. And I can create a scale for that. So the way that it works is that I can use a function like D3 extend to get the minimal and the maximum values that I have in my input array or in my data source. And from there, I use it as a domain to create a linear scale. This linear scale is going to map the minimum and maximum from my data source to the minimum in pixels and the maximum in pixels that I have as available screen space on that page specifically. So if I were to draw exactly what we have on the screen right now, I could do something like this. I would map through the elements that I have in my data source and call my scale function, passing in the data points for each one of the data points that I have in my array. So the first time that I call it, to get the X position of my circles, I'm going to pass in 0 as a data point, and I'm going to retrieve back 0 pixels. Then I'm going to pass in 250 as my data point and retrieve back 170 pixels. And lastly, 500 as a data point and retrieve 330 pixels. And this is like the too long didn't read version of Z3. You can, in this case, we are mapping data points to the horizontal position on the screen, but we could also use scales to map, for example, the size of the circles by using the radius instead of the CX position of the circles. Or we could even map the data points to colors to create like a color map. But everything boils down to scales. Okay, so this is like the building blocks of PolarisVis. Before we talk about what we did to reuse the code that we built for web in React Native, let's talk a little bit about the differences and similarities between React and React Native. So in React, we create our markup by using divs and paragraphs, regular HTML, old school. In React Native, on the other hand, we have to import the components, the tags that we use to create the markup from the React Native library. So you can see that here we have views instead of divs and text instead of paragraphs. We're still in React's land, so all of the common functionalities of React that don't rely on any browser API, we can still use. Like in this case, I'm keeping track of the count of the button by using a use state. The only difference here is that the button tag itself on the React Native version, I'm importing from the React Native library. It's very common for us to use hooks all the time. And in our code base, we had this use prefers reduced motion hook that uses window.matchMedia to check if a user prefers reduced motion or not for accessibility to tune down our animations. But because it's a browser API, we can't actually use that. React does have an accessibility info module, which we can then get the isReduceMotion enabled method from it and call it, and it's going to give me pretty much the same result. So in my native version, I'm going to call the accessibility info module from React Native, and on a browser, I can still call the match media. And lastly, but super important for us, because I mentioned that all of our charts are drawn with SVG, that's not something that React Native supports out of the box. So to draw shapes like SVG, you have to look for an alternative like React Native Skia, or in our case, we ended up using React Native SVG, just because it gives you pretty much the same API that you would expect from regular SVG. You can see that there I have a view box for the SVG tag, and all of the props inside of the circle and the rectangle are exactly the same. Okay, so how can we start thinking about extracting platform agnostic code from the original implementation of PolarisVis into something that we can reuse? Because, you know, okay, React Native is the future, but we have been working with PolarisVis to get it to the point that it was at that point in time for a couple of years. So if we just created a new library and called it, you know, PolarisVis native, it would be a lot of work to get that library to where the web version of the library was at that point in time. So what if instead we could extract everything that was platform agnostic into a third library, call it PolarisVis Core, for example, and then have the web version and the native version consume the platform agnostic code from core? Let's start with the quick wins. So everything that is just JavaScript, we can pretty much just cut and paste. So we had like lots of constants to keep things consistent, things related to theming, to animation configurations, spacings, styles, font sizes, etc., etc. Basically, everything that is a constant saving a value that we use just to keep things consistent, we can cut and paste. We also had a bunch of utility functions that, once again, just JavaScript. So, you know, things to handle unique IDs, to convert solid colors into gradients, to convert style strings into objects. All of those small utility functions, as long as they don't rely on any browser API, we just cut and paste and call it core. I briefly talked about themes and how it was very important for us to have like a centralized place where you define the styles of all of the charts across an application to avoid inconsistencies. And the way that we implemented it originally was also very easy to move to core, because out of the box, the library comes with two themes, the default one, which is a dark one, and also an optional light theme. A theme pretty much is just a big JavaScript object that has all possible styles that you would use in any kind of charts. Like, for example, not only what colors the bars or lines should be, but also if the bars should have round edges, if the lines should have harsh edges or not, etc., etc. So the library exports this component called Polaris Provider, which allows you to overwrite the default styles of the charts across your whole application. So you can see here that I'm overwriting the background color of my chart container to be blue, and my app is inside of this instance of the Polaris Provider. So anywhere inside my app, I don't have to pass any style prop, and the charts of my application are going to have the new overwritten background color. I could even specify multiple themes if I want. Like in this case, I'm creating a theme named Angry Reds and another one named Happy Green. And I can use those keywords, the names of the themes that I created on a provider, in any place of my application, as long as the components are children of the Polaris provider. It looks horrible, but it works. So the reason why we didn't need to change anything to make this work on React Native is because the Polaris provider in itself is just a React context provider. Under the hood, it uses memo to be able to memorize the values that are saved inside of the provider and allow you to overwrite with your own styles to your application. We also have this create themes utility, which is basically just a utility function that if you don't pass, for example, let's say what color the grid lines should be, it's just going to use the default from the library so that you don't have to write, 500 lines of styles for creating a theme. And once again, just JavaScript. There's nothing related to browser-specific functionality. So all of that implementation of themes, we managed to cut and paste into core. The same way that we managed to move a lot of utility functions, the same goes for hooks. So we also had a lot of hooks that extended the default functionality of D3. So things like use Y scale, use X scale, use labels that we basically use to calculate if the labels of a chart should be displayed horizontally, diagonally, or vertically, truncated or not, etc. All of those things, we just moved to core. And lastly, consistency, as I keep repeating, is super important in our library. We wanted all of the different kinds of charts that we have, for example, line charts, bar charts, donut charts. We wanted the user to be able to render the same data set without modifying the data in any shape or form and just choose a different component. And to make this work, it's very important that all of our charts accept exactly the same data series type. So we wanted to keep this consistency also in React Native. So that means that we moved all of our global types to the core library so that we can keep things consistent, not only inside of the browser version, but also the native version. Okay, so the original implementation of Polaris was composed of chart components. So that's like the top level chart components that actually put together all of the building blocks. The low level UI components, things like lines, bars, grids, legends, etc. The Polaris provider and everything related to themes that we talked about, types, hooks, and utility functions. And just with the quick wins, so things that I didn't have to modify in any form, we managed to move pretty much everything but the UI layer to Polaris core. Okay, so how could we share UI components? Because when we were comparing the implementation of React versus React Native, the main difference really is that, HTML versus components that you import from a library. But it would be very nice if we could, reuse those building blocks that we already have a very well-defined styles, like, the axes, or the legends, or each one of those lines that accepts a color and has a little gradient with this specific curved style. It would be very nice to be able to share that too. So the first approach that we did try was to use this library called React Native Web, which is a very nice library actually. It allows you to write React Native components, and it does everything that you would need to do to render your native components on a browser. So theoretically, we could rewrite our building blocks, the low-level things that we talked about, in Polaris core and use React Native Web to render them on a browser. And by doing that, we could then move the UI components to core and just keep on Polaris Web and Polaris Native the top level components that actually put everything together and creates platform-specific experiences. The problem with this approach, though, is that since Polaris Web would be using components, UI components from core that depended on React's native web, that means that the web version of Polaris that up to this point didn't actually need React's native web as a dependency, would need it. And remember that we talked about React's native not accepting SVGs out of the box. That means that we would also need to add React's native SVG as a dependency. And it might not seem much, but if you compare the bundle size of React's DOM with React's native web, you can see that it's kind of like, double the size. Shopify is a very complex system with a lot of dependencies already, and every seemingly small thing that we add can make a big difference to somebody that, for example, lives in a part of the world that don't have fast internet connections. So that solution was definitely not going to work for us. So the second thing that we tried was, okay, how can we share the UI components, but also keep the bundle size small? We already have the Polaris provider that is responsible for providing everything related to themes. So what if this provider could also provide a collection of components that would be platform specific? So basically, if you are in web, we provide HTML tags, but if you are on native, we provide native tags. This way, we could have a platform agnostic provider that lives in core and then re-export the platform agnostic provider with the correct components, both in web and in native. You can see that here, the native version of the Polaris provider, the first thing that I do is import the original provider that doesn't have anything platform specific. Then I also import all of the native SVG tags from the library that we are using, and I overwrite the components that live inside of my provider to be the native versions of things. So that's that bit there that says SVG is going to be a native SVG, a circle is going to be a native circle, rectangle, etc., etc. Basically, all of the tags that we can draw shapes with on SVG. And on the website, it would be pretty much the same thing, but instead of importing components from a library, because that's something that a browser already has, I'm just wrapping the default behavior of the SVG tags with the React Create element so that we can have exactly the same API with Pascal case and props to regular SVG elements. So this is the overall approach. And the way that this would work is, suppose that I have some shared components inside of Polaris core. This can be like a bar with round edges, a gradient, or whatever. Instead of using SVG, rectangle, circle, path directly, either from the library or the default one that we can use on a browser, we're going to get those tags from the Polaris context. So this means that when some shared component is used on web, it's going to fetch the regular SVG tags from the provider, and on native, it's going to fetch the native SVG tags from the provider too. So let's have a look at what this looks like in an actual component in the library. So we have this thing, it's called a Spark bar chart. And just for context, it's not something that is meant for you to dive into the data. It's useful when you want to show trends to see if something is trending positive, negative, give a glance in a context where the most important thing is not data exploration. And this is what the code for the Spark bar chart on Polaris native looks like. You can see that the first thing that we do is import all of the things that are shared and come from core, like the types, the hooks, and also the bar component itself. And later on, we use those hooks to get all of the functions that we need to calculate the positions and sizing of everything. And later, we use the bar components. Once again, this bar components under the hood is not actually drawing the path by accessing the SVG library directly or drawing the SVG browser version directly. It's fetching the path from the provider. And because we are in the Polaris native library, it knows that it should use the native version of the path. So in this case here, it's looping through the data points and rendering one bar for each of my data points. Okay, so everything that we talked about today was pretty much foundational work that allows us to think about future possibilities of data visualization in general, and more specifically about mobile data visualization. So if we think about something like this, right, it's a nice experience for desktop. You can hover on things, interact with elements, you have your tiny cursor and the tooltip following you around. But if you just shrink it down, not the best experience. You know, it looks horrible, and your thumb is on the way of what you're trying to read on the little tooltip. So that's definitely not the solution there. And I think that what's nice about an approach that you basically just share the building blocks, but you still keep the experiences separate, is that you can think about how to take advantage of the platform agnostic, the platform specific features of the project that you're working on. So in our case, a much better experience probably would be to take advantage of gestures, since we are using a touchscreen device, to, for example, pinch to zoom in and out of a range of data in our charts, or maybe use, 2 fingers to scroll outside and 1 finger to scroll inside of whatever data is currently visible. Maybe we could take this even further and use the Human First API to train a model to allow me to say, show me the data from June 8th to June 10th, and the chart automatically filters it down to show that data for you. Yeah, so as I mentioned earlier, PolarisVis is already open source. So if you're interested in data visualization, go ahead, have a look at the docs, maybe consider using it in your next application, or contribute to the library. This is all that I had for today. If you have any questions or comments, I'll be around, or feel free to reach out to me on Twitter. My username is CRYSTAL CAMPIONI, and that's it. Thank you.